Is chemical engineering the right major for you? Are you looking for the right major to follow your passion and succeed at school? Well, this tutorial video will help you to identify whether chemical engineering is the right major for you. You may say that you are good at math and chemistry and that you would like to combine those subjects to solve real problems. Nevertheless, those subjects may be applied in different ways that may not like you. So choosing the right major seems to be a meaningful decision for you. But don't worry, we have a solution and we hope you find this tutorial video very useful. There are many questions that you may ask yourself to identify the right major for you, such as what if I don't like the way in which math and chemistry are applied, the subjects and the topics of the major are not what I expected. This tutorial video will help you to avoid surprises because we will explain briefly a topic that you will study at this school. After that, you can ask yourself honestly whether this major is right for you or not. First, you should remember that chemistry is everywhere, and it is involved in many natural phenomena. So let's briefly explain the evaporation phenomenon, in which the water changes from a liquid phase to a vapor one. You will notice that this phenomenon is described through mathematical formulas when you study a major in chemical engineering. And you also can notice this phenomenon when the water of the ocean evaporates and reaches the clouds, as we can see in this animation. Another phenomenon that you can notice is the water condensation, in which the water changes from a vapor phase to a liquid one. Some formulas are described by this phenomenon. You can notice this phenomenon when you hold a glass with some ices in it, and then after some time holding the glass, you will notice that some water droplets are formed around the glass. This means that the water in the air condenses and accumulates on the glass. Here is an animation of how the droplets are formed in real time. Now that you know that chemistry is everywhere and the mathematics translates a phenomenon into something mathematically tangible through formulas, a chemical engineer learns how to manage and transforms fluids such as water to do a work or to create a product that the market needs. You will study the industrial processes and fundamentals to do that. You will study the Carnot cycle, which is a process in which you apply condensation and evaporation fundamentals to produce a tangible work, such as one of a refrigerator. The refrigeration cycle is the reversed Carnot cycle, so it will be very important for you to understand this topic. We will explain you this topic very briefly. You will learn that a real refrigeration cycle functions with four main components: an evaporator, a compressor, a condenser, and an expansion valve. The condenser and evaporator follow the fundamentals we explained earlier to adapt the physical and chemical conditions of a substance. You can see in this image how the refrigeration cycle is composed of, and you can see how a substance enters the condenser, appears here as a saturated vapor, and is cooled to the saturated liquid state in the condenser, and then it is raised to the evaporator pressure, and it evaporates as it absorbs heat from the refrigeration cycle, from the refrigerated space. You will not understand completely what we are talking about, but the important thing is what you notice is that a fluid has properties and graphs that you will be able to understand when you study the major degree in chemical engineering. You will also study how to identify the phase and conditions of a substance in an industrial process. You will also learn about the temperature volume graph, as we can see here. And there are many other tables that will help you to transform raw materials into something useful, but the ones mentioned here will help you to learn more about the refrigeration cycle. So once you learn the chemistry and mathematical fundamentals of different phenomena, and that you can monitor and manage raw materials through graphs, you will start integrating all the knowledge into a process to transform raw materials into tangible products. You can now see that we can use different machines and fittings to apply the fundamentals of the refrigeration cycle, such as a valve, a, here it is, a condenser, here it is, an evaporator, here it is, and a compressor. Also, you can see in this image how a substance follows the refrigeration cycle and it changes from the vapor phase to the liquid one. Here the arrows red and blue identifies which phase we are talking about. The refrigerator is an example of an equipment that freezes products in our home, and it is a real application of the fundamental that we have explained in this tutorial video. We can see in this animation how the refrigerant flows through the refrigeration cycle and it freezes. Here you may notice how the fundamentals that we have discussed earlier are integrated. Here you can notice how the refrigerant flows through the refrigeration cycle. Of course, with real applications are much more complex, and there are many other formulas that are involved. Please note that this is a brief explanation, and there are many other details and interesting topics that you will learn in this major. We wish you good luck, and we hope that you select the right major